Hi everyone, welcome to a brief overview of just passing parameters through recursive functions and how we can actually keep track of these values going around. As a general reminder of how this concept works, there's something that's in the background of your computer and your Python code called a memory stack. We usually refer to it as stacks or just in general things that keep track of values. So whenever we make a variable, like say in my Python code I do something like a is equal to 5, there's actually something on the stack that's made that has some memory here where I have a value, a variable memory stack called a, and it points to something called 5. Now, when you go to CSC242 and later courses, you're going to learn a lot about the assembly and like how this actually looks in code here. But for our purposes of this class, we want to look at the memory stack and how functions are called. So also when we make a function, so whenever we type out def, that also creates something on top of our stack here. And we can kind of just consider it at a high level of just this plate that we put onto something. So if I have a function call where I call it with a variable, like a of 5, say I have a function that's called like this, then I have something on my stack that says, okay, the user made a function called with the value of a of 5. Now, why is this important to know about these stacks? Well, the reason that we need to know about this is because when we look at our recursion, we're going to be using stacks to keep track of different types of memory, okay? So right here, when we're using these memory items, whenever we take a look at our code, we're going to have something like def of a of, let's put in two variables like n and k. And then what I'm going to do here is I'm going to want to try to make sure that I have n, if I put it as a variable up at the top, do it this way. So if I put in n, give me all the values of subtracting from n to k. So I want the output of subtraction from all the values of n to k. So again, if I have 5 and then 1, I want it to output what the value of 5 minus 4 minus 3 minus 2 minus 1 is, okay? So that's what my general idea here is for this piece of code. And what I would like to do is try to output a way to do this properly. And again, if we just go ahead and say our n minus 1 and then k here, let's do something like this. And then I try to do something like a of 5 and 1. And let me actually make this, instead of this function called a, I'll call this sub numbers or sub num, like so. Let me visualize this execution. We'll see we get a recursion error, but you could see here that this sub num with these two variables is what our stack is. So when we call something like sub num of 5 and 1, this is placed into our memory stack. And usually a good way to look at this is actually looking at the bottom. We have our stack here of 5 and 1. And then if I keep going with my code, we'll notice that my stack keeps getting added with functions. Okay, so this is a general idea. I have then 4 and 1, and then 3 and 1. But you'll notice here that we're getting recursion errors. So how do I actually solve my recursion error? Excuse me. Well, in general, if I want to go down until n, or excuse me, until k to subtract all these values, I could just go ahead and say if n is equal to k. And what that will do is essentially my base case that says, okay, well, we're done trying to subtract these values from each other. So now we hit our final base case and we're going to return from it. So I'm just going to hit return for the time being. And we can just go ahead and visualize this execution. And you'll notice that what we get here is once I go ahead and get to my base case of 1 is equal to 1, I just return. But you'll notice that my stack has a return statement now. So you can kind of think of this as like maybe putting an R inside of our stack. Let me go up to 2 and 1. Let me just do a return statement right here. Apologies for my writing. And you can see here now that I have a return statement, but my return value, if we take a look at our code, I'm returning nothing. I'm returning a none after it. And what that will pretty much say to me is that, okay, well, go ahead and pop this from the stack. And this is the main point of passing variables between each other in recursive calls. We could see here that when I pop this guy from a stack, I still have the remainder of these stacks here. And these guys also have return statements still built into them. For the time being, they're a none-return type. They don't return anything, similar to how print doesn't return anything, but they still need to execute their code. And we can see here that you have this kind of red line underneath it that we need to execute. And you'll notice that the line is actually pointing underneath our function call because there's nothing to really execute, but we still need to do it. And we can see we just popped them off the stack. And essentially, if you're ever kind of confused about this idea of why am I getting a value after my code ends, you can kind of think of it as that all these guys are a stack of plates. And let's just say that you're working, you need to remove the plates from on top of each other. If you remove the top plate to clean it and then you're done with it, you still have a bunch of plates remaining and you can't just leave them there. You need to try and solve them. So what you need to do is also pop these guys from your stack as well. And that's the general concept that we want to build out here of how we can get these return values working for us. So again, if you're asking now, okay, well, how do I actually pass a value back from sub number here? Well, what we need to do is instead of just returning a nothing in this scenario, I could try to return n here, or let me try to return, let's just say return 1, and let's visualize this execution. And we'll notice that when I get to the sub number of n and k, I'm actually returning the value of 1 here. So now that I'm returning the value of 1, it's going to pop up here, but you'll still see that the rest of my plates, quote unquote, aren't returning anything. So this guy's returning 1, but these guys here are returning the none type, which is an error for us, okay? So how do I make these guys not return a none type? Well, what we need to do finally is tell us to return the return something here that we need to use. And you'll notice here that if I actually return subnum and just that value, what will actually be returned, let's take a look at what's actually returned here. You'll see I get return 1. The value of 1 is returned each time because what is the final output of this code right now? Well, I just need to return a value of 1 at the end, and then that value is passed through all my other stacks up here. Now, that's not what I wanted, though. I wanted to do the subtraction of each of these guys. So what do I need to return here? Well, if I'm trying to minus 1 to 2 and 3 and 4 and 5, we'll see here that what I should return actually is n minus the remainder of this code here. And what this will do is at the end, it's going to return 1. And then what it would do is it will say 1 minus 2, 3 minus 2, 4 minus 2. Let's actually see this happen here. We'll see I go down to the very end of my code. I return my 1. I jump up here. And then I get return 1 minus sub number. And we'll see here that this becomes 2. And then this one becomes 3 there. So my code is working a bit differently because I'm doing subtractions here. I might actually go ahead and just do an addition here to program out this a bit better. But we can see here that I'm changing these values. And we'll see here that what happens here, the subtraction get a bit hazy because I'm doing negative subtraction. So I'm doing like 1 minus 2, which is negative 1, and then negative 1 minus 3, which is going to be 2. So it's kind of jumping around. But we can see here with addition, it might be a bit easier to see. We can see I go up to 3, and then 6, and then 10, and then 15, which is what I wanted. Let's actually kind of programmatically build this out here. So if I visualize this execution, let me go until the end. So this guy returns a 1. And then my code needs to run, which is right here. So what I get here is the value of n minus 1. So this code right here is going to be n, or 2 minus 1 because n is 2. Remember, my n's are over here, which is also equal to 1. So that's why I have a return value of 1. What's this one right here is 2, because why is it 2? Well, I get 3 minus 1, which is 2. And then I go to the next one, and it's 4. So what do I get over here? I get 4 minus 2, which is also 2. And then what's my last one? I get 3, because I'm doing 5 minus 2, which is then equal to 3. Okay? And you can see here that we're actually kind of doing this backwards, and this is the concept of backwards recursion. We go to the end and then go back up. But essentially, this is a general idea of how we can approach this problem and then getting it to work for us there. Okay? So this is just a general idea of passing parameters. Please use Python Tutor for this one. It helps a lot, but that's the idea of stacks and passing parameters there. Thank you, everyone.